Hello and welcome everyone to today's developer coaching webinar. My name is Tara Van Cleve and I'm part of the technical marketing organization here at Oracle. Today we're excited to show you how to use Oracle Apex to create and visualize graph datasets and how to integrate OCI Generative AI to add chatbot functionality to your application. So I'd also like to note that we are recording the webinar and you will receive the replay via the same email that you registered with after the event concludes. So if you do have any questions, we've enabled the Q&A section of the Zoom and we'll answer those throughout the hour as well as leave some time at the end for any remaining open questions. Today's webinar will be presented by Matt McDaniel, Staff Cloud Engineer. So without further ado, Matt, take it away.
All right. Thank you very much, Tara. Really appreciate it. Good morning, good afternoon, everyone. Really appreciate you all joining us here today. Today, we're going to talk a little bit about Oracle Graph and how you can create GraphRAG applications using Graph as well as generative AI. I'm joined by our product manager for Graph, Rahul, who will help you all with questions and answers. So please feel free to drop any questions you have in the Q&A. All right. So before we dive too deep into it, let's talk a little bit about what kind of tools we will be using when creating this generative AI LLM-based application. So first and foremost, this application is built entirely on top of the autonomous database. So we will be using Apex for that front end. The back end, we have the property graphs. So we will be using autonomous database to create and modify property graphs that we will be using in this application. Now, optionally, we have two items next that we will be using for the back end of the application. So we will be using OCI functions. Essentially, we're using this to orchestrate calls to our LLM, and we're using LangChain within that function to support integration with Oracle Generative AI. Lastly, we will be using OCI Generative AI as we will be using the pre-trained models that are used within that. Okay, let's talk a little bit about Graph first. Do a little bit of pre-work and then we'll get into the demo. When I talk to people about Graph, I typically phrase it in the context of your relationships because that's what graphs are particularly good at. And not just relationships, but relationships that are complex and have many different degrees to them. So for instance, you might have a data set in which you need to answer the question, does a particular entity rely or have a relationship with another entity? Now, of course, in many cases, we will have entities that have direct relationships with other entities, such as being connected by an edge, or if you consider it in the context of a relational database, you might have a foreign key that is connected to another. However, relationships are often not quite that simple, and you need to look into multiple levels of relationships, multiple layers to this. So for instance, we could ask ourselves, does A depend on F here? Now, it doesn't directly depend on F. However, if you traverse the graph, you can find that eventually, yes, there is some sort of relationship between A and F, and you can find that using a graph. The great thing about graphs are that they are very simple to understand. You have a node and you have a vertex. Or sorry, you have a vertex and you have an edge. The vertex has some properties uh, related to it, and they typically represent some sort of entity. An edge, in this case, represents some sort of relationship, and then an edge being connected to two different vertices means that there's a relationship between those two. Another great thing about graphs is that pretty much everything can be represented as a graph. So in this case, you could have like a logistics use case that can easily be relayed as a graph. We can discuss things like hierarchies, customer sales, things of that nature can all be represented by graphs. The most common example, and one that I will be showing you today later on, is social networks. So this basic example here is you could represent people as vertices and those people's relationship with others as edges. So they can be friends with others, and so on. Using graph analysis, we can automatically identify important entities within these graphs, such as people with many connections, people who have connections to people who have many connections. Um, if you're familiar with the 6 degrees of Kevin Bacon problem, it's the idea that um, how many degrees away are you from a particular person, right? You might be surprised to find that it's very common for us to actually be much more closely related to someone else than you might otherwise expect. Last thing I want to relay here is graph databases explicitly store these relationships. So in a standard relational model, you might have relationships defined as um, foreign keys, for instance. Those are not explicitly defined relationships, they are implicitly defined. With graphs, we can actually explicitly define what these relationships are. And this has further benefits when we're talking about RAG or retrieval augmented generation and how that can benefit an LLM to see what these explicit relationships are. Before I go further, just to mention, all of this graph stuff I'm talking about is available in Oracle database. It's been there for a while. You can use it with no additional cost in your uh, database. It's very simple to use. The query language is very easy to learn. And even in 23 AI, you can now use SQL to query these property graphs. And lastly, actually, I do want to mention existing data can be analyzed as a graph. So we don't need to recreate our schemas, don't need to re-import any data. We use the existing data that you have in the database, but we model it as a graph. How do you actually work with graphs? So we have a couple of options when it comes to actually visualizing these graphs. One of those is Graph Studio. If you're using an autonomous database today, you can go into the OCI console, go into the tools section, and you can find Graph Studio here, and you can use it today. It's fully self-service. It's managed by Oracle, and it's deployed within each autonomous database. It's a great tool to use for creating the property graph, uh, querying the property graph, running graph algorithms on your property graphs. Um, And yes, you can create like notebooks and things of that nature and share that with other users to analyze your graph data. Another option, and this is the one we're going to be focusing on today when it comes to actually developing the application, is the Apex Graph Visualization plugin. So if you are an Apex user, this is a plugin that you can import into your Apex application that allows you to visualize these property graphs. All you need to do is install a plugin. It's very simple to do. You just run a simple SQL script, and then you create a new region in your Apex page, select the type, graph visualization, and then you write a SQL query to um, to actually display what's in that property graph. Okay, now to move on to RAG. So what is RAG? So RAG stands for Retrieval-Augmented Generation, and it's a method in which you can combine your prompts with business relevant data in order to augment the response from the LLM to enhance the results of that data. For instance, LLMs are not trained on your own business data, nor should they be. However, you still want to get an accurate response when it comes to talking to an LLM and seeing what the result is. Typically, what people do is they might insert some natural language prompt, and then that natural language prompt should be converted into some either you can vectorize that natural language and then compare that vector with vectors stored within your database. This is known as vector similarity search. We won't be going too far into that today, but we do have examples of using vector search for RAG. Another method is to use something like Select AI. And If you're not familiar with Select AI, it's essentially just a way to turn natural language into a SQL query, run that SQL query, and then you send that data to an LLM to augment the response. So that's RAG. But what is GraphRAG? So GraphRAG takes the benefits of using a graph, that is, being able to represent complex relationships in a data set, and use that to augment the response that an LLM will return to us. So the idea here is we want to retrieve these nodes and these edges, and then we feed it into the generative AI model. So for instance, a user could have some sort of query. The user submits some sort of property graph query. The database runs that property graph query and then submits the results to an LLM. Now, this is mostly dealing with structured data. You could also do this with unstructured data as well. But the idea here is we want to use the enhanced capabilities of a graph to actually return an accurate response to the user. Okay. Another thing we will be using here is the Oracle Generative AI service. The Gen AI service is available in OCI, and it allows you to use pre-trained models to implement RAG. So that's how we're going to mostly be using it today. This is fully hosted within OCI. You don't need to train your own models, although you could if you would like, and it's private and secure. So none of the data that you're sending to Gen AI is going anywhere else except for Gen AI. One second. Okay. What models do we have available in Gen AI? So we have Llama and Cohere. Today, in this particular example, I will be using the command R um, model, largely because it accepts a large amount of tokens and it is good at summarization. Okay, the demo architecture. So what am I actually showing you here? So the general flow of this demo will work as follows. So the user will write a property graph query. This property graph query will be processed by the database and then visualized on the Apex application. Then what the user will do is submit a natural language query, and then in turn will send the edges and vertices from that displayed property graph in Apex to our LangChain application. And if you're not familiar with LangChain, LangChain is just a framework for you to chain together prompts and augment prompts before submitting to an LLM. It does much more than that, but that's how I'm using it in this particular example, is to orchestrate and to facilitate communication with Gen AI. Earlier, I mentioned this was optional. You do not have to go this route. You do not need to use a function or LangChain to actually implement RAG in this scenario. This is just how I chose to do it. For instance, this could all be within Apex, and then Apex talks to generative AI. That works as well. All right, let me show you the demonstration. 1 second. Okay. Okay, first thing I want to do is show you Graph Studio, where we will actually create our property graph. So once you're in Graph Studio, which you just go to from the OCI console, and you go and create the graph, uh, you'll be met with this graphs page, and we can click Create Graph. Now, in this case, I'm actually showing you multiple data sets. I don't just want to work with one, but I'm just going to, for the sake of an example, show you how you would create something for an existing schema you have within your database. So for instance, I have some banking data. So if I give it a name, something like banking, if I can spell, and then you choose what tables will actually be a part of this graph. Keep in mind, we're not creating new tables. We're not importing new data. We're just using existing tables. So for instance, I can choose, in this case, I have bank accounts and then I have bank transfers. I want to move these over to the selection. I want to choose the type of graph to be SQL property graph. And then it will show me what the graph will look like. I can check source to see what the source code is for that particular graph, and then designer, I can see what the sort of the schema looks like for this property graph. You can see I have this bank account graph node as well as an edge that's called the bank transfers graph. Once I have that, I can see my vertices here and my edges here. So another thing I'll note is when you click on these, you can actually see the properties. Now, what is a property? A property is essentially a piece of information tied to that node. These bits of information come from the graph itself, or sorry, from the table itself, such as columns within that table. So in this particular table, I had the bank account balance, the bank ID, and the name. I can import these here, and then optionally, I can give it another name. Now, this could be important in cases or when we're discussing about RAG, because you would want your columns, in this case, or your properties in this case, to be named something that an LLM can interpret fairly easily. In this case, balance is it's very easy to understand. If I have a bank table, balance represents the amount within that account. However, I understand that in many cases, you may have column names that do not actually are not very easily recognizable as representing that particular thing, such as, say, you might have sales order numbers within a column, but the name of the column is something that may have particular domain knowledge or have a strange name to it where it might be a little bit difficult for an LLM to interpret. In this case, I'll leave it all blank. Um, let's go next. Now, I did already create this, so I think it might just error out. Nope, I recreated it, so that's good. So I created the graph. Now you can actually go to the notebooks and query these particular graphs. So for example, if I go to banking, I created this notebook earlier. It will attach a compute environment for us to load this into memory and then actually run some queries on this particular graph. So I'll take a couple of seconds, but once that's actually done, you can see I actually created this query before, and you can actually see the results of that particular graph. So once we actually create the graph, we're good to go. Now we can move over to Apex and actually work on the application. And the anatomy of a graph query is fairly simple. You have the select statement, and you tell it to search from a particular graph table, and then you give it a vertex, an edge, and a destination vertex. And these can be much more complicated if you want them to. Say you have multiple vertices, different types of vertices, you have different relationships. You want to model all of those relationships. That's definitely possible. You can see here that this particular query returns these results. You can see all uh, these are bank accounts and the particular relationships they have with other bank accounts. In this case, they are bank transfers. So this particular account here, ID 186, sent $7,000 to this particular bank account. Okay, now let's move over to the Apex side because now we have our graph. Now let's actually visualize that within an Apex application. So in this case, when you create an Apex application and you import the plugin, all you have to do is create a new region, go to type, click on graph visualization under application components, and you're pretty much ready to start writing queries. Now we have multiple ways you can actually write a SQL property graph query within the plugin. Personally, I like writing the SQL queries because I just like knowing the exact query being written, and that's what we'll do here. So if I were to, actually, I won't actually show this because I already have some visualizations here. But once you actually do that, you can run the query and visualize that graph. So now let me talk about the chatbot components of this. So I will first actually demo what this looks like. Oops. Okay, so I have a number of data sets I'm showing here, and I pretty much tailored them in a way that I can ask questions and have it make sense. In this particular case, I have a friend network, social network, as well as a network of reviews. People can write reviews to restaurants, and people can be friends with other people. Now, the idea here is I might want to create like a recommendation system where I want to recommend certain restaurants to people in which there are good reviews for those restaurants, and maybe I want to give recommendations to friends of those people who give good reviews to restaurants. Maybe I want to avoid giving reviews to people who have rated a restaurant poorly, for instance. So in this case, oh, sorry, my everything, all my screens just went black for a second. So here you can see this particular visualization is called five-star reviews, and this is what it looks like. These are all of the restaurants within my graph and all of the five-star reviews for these particular restaurants. So you can see if I right click on these, we can see the restaurant cuisine, French, the name of the restaurant, and the restaurant ID. If I click on these edges, you can see these are the reviews. So this particular user, user49, gave this review, and the actual don't worry about the review text. It's just randomly generated, so it doesn't mean anything. However, there's also a rating here, such as 5 stars. These yellow vertices represent the people within the graph. So in this case, this is user ID 75. This particular user, user1, submitted a review for restaurant 5, and that's what the edge represents. Okay, now how do we actually implement a sort of a chatbot for this? In this case, I have two boxes here. I have an explain box and a chatbot box. The explain box essentially will tell me, what does this particular visualization tell me? What am I actually looking at here? Of course, if I click on these and I read the information in here, I can gather what I'm actually seeing, but maybe I just want a description for this. So if I click this, it may take a moment because I have to call an OCI function that has to wake up. It's been a while since I actually called it, so it might take a little bit to do that. But just to look at the data again, you can see it's organized in such a way that I have most of the people on the outside and the restaurants in the middle, and some of these people got stuck in the middle as well. But the idea here is you would want to ask questions about this visualization, such as how many people have reviewed this restaurant? Um, you know, what are the ratings for these particular reviews? What do they mean? What kind of cuisines do people like? Right? Do they like French or what have you? So we'll give this some more time to actually show up. I will give that a moment. Actually, while that's going through that, I can actually show some of the other visualizations. Yep, so it's still processing. The other visualization I have is for a particular restaurant. What are the reviews for this particular restaurant? Now, this isn't just 5-star reviews. This can be any rating. So rating 4, rating 3, rating 2, rating 4, right? These are particular reviews for this restaurant. Now, this particular graph, maybe I want to ask questions like sentiment analysis. How do I, or like, what's the general view of this restaurant from people? Maybe I just want to get a few reviews just to see what people are saying about this particular restaurant. The next visualization I have is a little bit more complex, and that is to describe friends with friends who have reviewed a particular restaurant. So you can see I have a bunch of vertices here and edges. This yellow vertex in the very middle represents the restaurant. In this case, It's this Thai restaurant here. The green edges represent the reviews for that particular restaurant, and the yellow edges represent the friendships. So the idea here is I want to be able to find um, or recommend this restaurant to people who have left good reviews for it. Uh, and perhaps I can set up a priority system where, should I recommend this restaurant to a person with multiple friends or with a few friends, and whatnot. So let's go back up here, and it looks like it did finish. It should be much faster from now on. So in this particular visualization, I asked it to explain, and the only prompt I give to this is just explain what you see in this data set. What is actually being visualized here? In this case, the response from GenAI was, this data set appears to be a collection of restaurant reviews and user information, contains details about restaurants, IDs, names, and cuisines, includes information about users who have reviewed these restaurants, such as their user IDs, and so on. And it also tells me a little bit about how the relationships are structured. It contains two sections, vertices and edges. A vertex with the ID people1 is labeled as a person, has these particular properties associated with them. And then it also tells me the edges. What are the relationships here? So each edge has a unique ID, labels, and properties. An edge with the ID reviews one user ID represents a review by that particular user. So that's good. It explains what the data set is, but what if I want to actually ask questions about it? For instance, maybe I just want to get a basic idea of what reviews are currently here. So I can ask it a question like, please retrieve all reviews for, and let's just find a restaurant here. Let's restaurant 3 for restaurant 3. And then I can ask it that question, and then it returns a response and just gives me some reviews for that particular restaurant. Now it's gibberish, so I wouldn't look too deep into it, but it can give you information about this particular visualization. So very good if you just want to ask some basic questions about particular graph visualizations that you have here. Now, if we move on to the next data set, the reviews for this particular restaurant, let's explain. Let's see what it tells me. Yep. So this data set appears to be a collection of reviews for a French restaurant called Garcia Reed. It's written by various individuals, each identified by that particular ID. It contains information about people who have reviewed the restaurant and reviews themselves. They're labeled as a person. Um, the edges in this data set connect the reviewers to the restaurant. And it has a review on a rating of a scale of 0 to 5. So in this case, it just tells me a little bit about this visualization. It's just people reviewing this particular restaurant. Now, I might want to ask, what are the reviews generally like for this restaurant? So I can ask, what is the general sentiment of this restaurant? I'll ask that. It's generally mixed, right? Out of these reviews, 11 are positive, 8 are neutral, and 10 are negative. So you probably don't want to recommend this to many people since the reviews are so mixed. For this particular visualization, this is a little bit more complex because we're introducing another relationship into this graph, which is friends of people who have reviewed the restaurant. So let's go ahead and explain that. And while that's doing that, I can ask some questions. So I want to recommend this restaurant to some people. Do you have any suggestions? And let's see what it says. So you can see it when I explain this, it just tells me a little bit about this particular visualization. It's a lot of it's the same as before. Um, Okay, so I asked it if it had any suggestions. So it's telling me I could identify the users who have reviewed the restaurant, right? Those are relevant within that data set. Analyze the ratings and reviews, prioritize users with positive reviews, consider social connections, such as if they're friends with them. So if I say, okay, let's find people who have reviewed this nicely, and then let's compare it with someone else who say hasn't reviewed it nicely. So this particular review left by user ID 25, they left it at 0. So they were not fans of this particular restaurant. So let me copy that and ask the chatbot, should I recommend this restaurant to user 25's friends? And let's see what I get from that. Yeah, so may not be advisable to recommend this restaurant to user 25's friends as the average rating is relatively low. So the idea here is that maybe I shouldn't recommend this to certain people based off of data within the graph. Okay, the last example I can show here is something like bank accounts. So in this case, this is a completely different data set. This is actually what I created earlier in Graph Studio. It's just a data set where it shows accounts and transactions to those particular accounts. So if I click explain, it'll tell me uh, that the data set appears to be a record of bank transfers. Each entry represents a single transfer, so on. Now I can ask it questions such as, for a particular account, what is the highest transaction that it's made to another account? So for instance, let's just pick one here. Let's say 249. And I could say list all, let's say outbound transactions that have been performed by account. I'll say bank account ID 249. Right. So here you go. So I asked it for these particular transactions for account 249 and it returns these values. So in short, that's pretty much um, how you could implement the like chatbot capabilities into the graph. Now to actually show you how it's done, I'll go back into the app builder for Apex and show you how it's implemented. So there are three things that we need to consider here. We need to consider getting the data from the graph itself and then submitting that data to our LangChain application. And then how does the LangChain application actually connect to generative AI? So in Apex, all I did was create a button in which there's a dynamic action here. That dynamic action creates, runs some JavaScript. And the JavaScript is pretty simple. All it does is it gets the edge data and the vertex data and it submits that to a backend process, which I'm calling called Gen AI here, using the apex.server.process command. And then if we go to the actual backend process, all I'm doing here is I'm taking those vertices and edges and submitting that to my function. And earlier I discussed how this was optional. You do not need to send it to a function. In fact, you could submit it here if you did not want to use, say, LangChain um, for actually orchestrating that communication. Once I submit that to my function, I will show you the function code. And the function code is very simple. All I'm doing is I'm creating an instance of Chat OCI Gen AI. This is the integration that LangChain has with Gen AI. And I'm giving it a template. In this case, I'm telling it I have a data set here that I want to analyze. Now, you may find that you may have to add some more to this to give you the best results, such as describing what does the graph data look like. For instance, tell it that you have a source vertex, a destination vertex, you have edges. You don't need to tell it what the business information actually means, but you need to tell it maybe a little bit about how the data is structured. So apart from that, you just give it the data that we submitted to the LLM or to the function, and then we invoke that LLM using the data that we provided to it, and it returns the result back to the user. Once that data is returned, we actually see it here in the chatbot here. And that's all done through uh, the JavaScript code. So I know it's maybe not as low code as some would prefer. There is a little bit of coding here, but the coding is generally fairly basic. We're just submitting the data to the LLM and getting the result back. All right. Now to go back to the presentation for one last second, I just want to share some of the findings here and some caveats to this. So as you saw in the demonstration, the chatbot capabilities were per visualization. That's due to the nature of how I implemented it, which is I submit the data just for that particular visualization to the LLM uh, to analyze. The reason I did that is because uh, when you submit data to an LLM, you need to be conscious of the number of tokens that you're submitting, right? If you have a massive amount of data, it could be a little harder to analyze and perhaps the performance could drop off a bit there. But how I'm doing it here, it's very small. The amount of data I'm sending is very small. It's very easy to analyze that data. Another consideration here is that the edge and vertex properties should be named in an LLM-friendly manner, which I discussed earlier. The reason is you're sending those properties to the LLM to analyze, and if you have domain-specific language in there, it could be a little bit harder to analyze. Something that you probably also noticed with that demonstration was that the data I submitted was all structured data. It was all graph data. That being said, that's not a requirement here. You can also use unstructured data as well. And I know we have a presentation that was done by the graph product management team about using vectors and graphs, and I believe Tara uh, uploaded that to the chat earlier. Now, the last consideration, of course, is there is some coding required on the Apex LangChain side. Again, if you would prefer not to use LangChain, if you want to call Gen AI directly, you can definitely do that. It's not a requirement. I personally used it because of the integration it has with Gen AI, and I can chain different templates together, which is very nice. All right. So that's actually everything I had to show. If Pete, you want to take over for the Code Innovate side?
Absolutely. All right. Well, hello, everyone. My name is Pete Madura. I'm a member of the Code Innovate team here at Oracle, and I want to take just a few minutes of your time to tell you all about the Code Innovate program. Simply put, it's an enablement and training program for new and existing Oracle customers, supported by a team of deep dive engineers like Matthew and myself. So, what does this program offer? Well, we start by reviewing your strategic use cases which require technology to solve. We then pair that use case up with our engineers who have deep experience developing on the required service or services and potentially with similar use cases. And with our guidance, we help we help your organization deliver a first pass prototype of a desired solution. So let's take a closer look at the framework of the program. These are 1 week long virtual events. We typically facilitate these through Zoom, and you and your teams are driving the development. So, in a sense, we are just over your shoulder showing you and discussing with you how to build out the solution. Now, a single event runs for 4 hours a day for a total of 20 hours for the week. And lastly, there is no cost associated with our time for this program. There might be cost associated with services that you need to provision and spin up, but not for the engineering time on these events. Here are some basic guidelines for an event. We look for two main things when understanding your use case. Do we have the necessary skills to support it? And can we fulfill the requirements in the 20 hours? I should also mention that we can support multiple use cases or teams during a single event. As I mentioned before, an event runs Monday through Friday for 4 hours a day, and we can accommodate most start times. And we look to get 4 or more participants from the customer. And no prior knowledge on Oracle services is needed. We usually need about 3 weeks lead time to run an event. And let's take a quick look at what goes into a typical event setup. Once we've agreed on a suitable use case, we will determine an event week. Essentially, once established, we will work toward that week. We will help you with any tenancy configuration that can include tasks like provisioning services, setting up new users, setting up data sources, networking, and things like that. We also offer what's called structured learnings, which is essentially training demos of the service or services we'll be utilizing throughout the week. Since many customers may be new to Oracle services, this is a great opportunity for participants to get some exposure to the tools they will be developing on in the following week. Then we have the event. If this program sounds like something you would be interested in exploring, there are several ways to get in touch with us. You can send us an email using the address on the screen right now. You can also add your name and email address in the chat right now in Zoom. And if you're already working with an Oracle account manager, let them know about your interest in the program. They know how to get a hold of us. Thanks, and hope to see you in an event soon.